Good day to you. This is Anagalactic on the first Sunday in May, the fourth day of the month, if I'm not mistaken. Yes, it's early morning here. This is simply to follow up on yesterday's video where we left off on this page over here with two related quantities of distance and redshift. We had been able to get as far as covering what is redshift. How do we know that there is a linear relationship on the cosmic distance ladder between distance and redshift? Well, it's because those lines that we talked about are interspersed throughout the continuous spectrum, which in the visible light range is in between infrared and ultraviolet, so that the lines could shift toward the red or toward the blue. There are blue-shifted galaxies in our local group, which consists of three spiral galaxies, our own, called Via Lactea, which is Latin for Milky Way, and Andromeda, which you can see with the naked eye, as it's said, and apparently a person with very good vision can also spot Triangulum, a smaller galaxy, which is a bit further off than Andromeda in our local group, which also has a plethora of dwarf galaxies, satellitic galaxies. So we were talking about extracumular space, which would be outside what is called the Virgo cluster, a larger collection of galaxies, could say around on the order of 100 rather than 3. And that's a typical size for a galaxy cluster, which I call a cumula. So ours would be the Virga cumula. M87 is probably the main galaxy, although there are several giant elliptical galaxies in the Virga cumula. And the reason I introduced extracumular space as a term which hasn't been heard until I invented it is to reveal to us, as layman scientists, that redshift is not the simple concept that it's presented as. When talking about the current model, the current cosmological model, there would have to be some kind of cosmological model because there are so many people now who are so inter-networked that the fact we've seen so far into outer space commands from the scientific community some theory of the universe. Now, in my opinion, this is merely my opinion, it is far too early to have a theory of the universe, but it is unavoidable, so I do accept that there would have to be some kind of tentative construct in order to explain what we see scientifically. Now, it is a difficult laboratory to work in because we're fully reliant on the light that comes from those galaxies. But it is miraculous, and this is a good place to begin in talking about cosmology. It is miraculous that that light reaches us. There's not an atmosphere in outer space. It's not considered to be a medium, although I'm sure that you heard in school that there had been a huge controversy about the existence of ether, which would be simply a word invented to describe what would have to exist, a medium for light to traverse. And yet, we cannot find any such medium. It does appear that empty space is simply empty space with no characteristics. Now, Albert Einstein changed that. Among his many discoveries, which can be characterized in different ways, his discovery of a characteristic of space was one of the most amazing discoveries in the history of science. I fully accept that, of course, but it is hard to interpret. And the reason, or I should say a reason, for the difficulties is that it's virtually impossible to explain scientifically how light traverses space, because shouldn't it disperse and just disappear. In other words, the stars should not, I'm just putting this fantastically, I suppose. How does starlight reach us? It certainly covers a huge distance. The nature of the propagation of light is part of the paradox, the quantum paradox. The reason we can say it's part of the quantum paradox is that a photon is a quantum of energy. This is undeniable in the sense that something traverses space that is coherent. It is information. And judging certainly from the analysis of spectrograms using spectroscopy, whereby we basically use a prism or a prism effect to spread out the light so we can see what's in there. And it's a range of frequencies, as you know, with those lines, which enabled Hubble to discern a linear relationship between distance and redshift. What causes redshift? Now that is actually a key to cosmology. So this was immediately pounced upon, that Edwin Powell Hubble's discovery, you could put it that way, he is given credit for that. It's sometimes hard to give proper credit where credit is due, because discoveries, certainly at this level, tend to be cumulative. And there's a threshold of understanding what is being seen. Well, Hubble made a tremendous discovery. It was inevitable that someone would discover it, but he just happened to be the man, the right place at the right time, right after World War I, which, by the way, was not called World War I until after World War II. I think you can see why. What was it called? It was called the Great War, usually, and World War II is often called the Patriotic War, I'll just say, in Russia, because that was really their first World War. But in between the wars, all of this discovery action began in astronomy, because the Mount Wilson telescope was so much more powerful, had such higher resolution, it was much more accurate. It had the power to discern stars in our nearest galaxies, and Hubble was the guy. He came back from World War I. He was a major in World War I. He went all the way to England, and I'm not quite sure if I don't know if he took part in any action, but he was called the Major. That was his nickname when he came back. One of the top astronomers. He certainly was qualified for his job. He worked hard, and it's hard work. Or it was at the Mount Wilson telescope, which is an amazing feat of engineering. I won't go into that, because what we want to do today is just wrap up what was begun yesterday. I had to cut the video off at 40 minutes because I don't like to go over 40 minutes. I try to restrict these to 30 minutes because this is YouTube video. People are as interested in sitting down to an hour or 2 hour lecture as they are to a 30-minute presentation, which is much more congenial, certainly to me, if it can be done. Now at this level, it's hard to do. So where we left off was with the Wikipedia article on redshift, which I recommend that you read the first 2 paragraphs, because all the propaganda is in there, and it is propaganda. I don't believe that that's denied greatly anymore. It was denied hugely, certainly up until the 1960s, and then, I mean, it has been, 60 years since that time. We're now in the 21st century. The propaganda finally had to more or less dissolve, because everyone knows that the Big Bang is trash. That we don't have the capacity as human beings, in any sense, at any level, to conceive of the origin of the universe. It's almost insane, Because when you consider we don't even find the edge of the universe, the James Webb Telescope cannot find the edge. There is no edge. Although, I shouldn't say that. We simply don't know if there's an edge. But once you get past the 10 billion, I mean, we're talking about gigaparsec. These are, well, we all know that it's huge. But there is no perceivable edge. What's going on at the cutting edge now, based largely on the James Webb Telescope research, it's quite a fascinating device, what it's capable of doing. But you see, now we're studying many more wave bands, because of course the electromagnetic spectrum is huge and we only see a tiny slice, as you know. But more telescopes have been invented. X-ray telescopes, gamma telescopes. The James Webb Telescope itself is engineered to focus, well, it's a form of focusing, on the lower. It's not strictly speaking an optical telescope, although it does cover the optical range. Its bandwidth is shifted towards the infrared because you can see farther. Why would that be? It's because as light travels through space, obviously it's expanding. It is a spherical wave front. So the further light goes, the more it has to attenuate in some way. Well, that's redshift. That's all redshift is, but it only in context. So it does not in any way imply expansion. There is no such thing as spatial expansion. That would be to apply another characteristic to space beyond what Einstein did. Now, what did Einstein find out? It can be interpreted in more than one way, but the correct way, according to the geometry that I use, which is spherical geometry, the nature of space is not so much that it is connected with time directly. There's an intermediary between space and time, because time is a derivative of motion. And a moment's thought may convince you of that, but even that it depends on which model you choose. And models should not be chosen, except for research. Models are to guide research. A theory is something that might contribute toward a model, because a theory is an unanswered question. And a theory, such as the Big Bang Theory, must be considered tentative until there could be some proof. Now, it's so fascinating, but it's actually kind of complex and convoluted, a bit complicated, to talk about what happened in the 1930s. It began very quickly that after Hubble discovered the linear relationship that we now know constitutes a cosmic distance ladder rung. The last so far, although even that is contested, a cosmic distance ladder rung is a method of proof. For instance, how far is it to the moon? How far is it to the planets? How far is it to the nearest star? Each one of these requires a different logical approach, and each rung has been climbed until now. We want to know how far away are the most distant things in the universe. Well, we have a cosmic distance ladder rung called redshift, and that is valid. There is no denying that there is a linear relationship, but it doesn't apply in our local space. So this is very important for getting distances to galaxies that are further off than our own cluster, and that's a fair statement. It's in books, so remember that when the discovery occurred that there are such things as galaxies, that was an enormous breakthrough, because nobody had seen anything, that is, been able to prove that anything was outside our star system. Nobody knew what those fuzzy things were, such as Andromeda Galaxy. And I shouldn't say nobody, because for 50 years before Hubble, there was spectroscopy. And you need photography for that, but within that 50-year range, before 1926, there was photography. It was invented just in time so that spectroscopy could capture the light with photography so that the light could be analyzed. You have to have photography for that. I should say to get the information that you want, because you can gather more photons with photography than you can with your eye or any instrument. It has to be cumulative to pile up the photons. Now CCD is used, and that's quite extraordinarily accurate. So we have improved our range, that is our resolution and ability to interpret what we see. But the first discovery was those things are on the order of 1,000,000 times further away than the stars we see. That Andromeda is that much farther. It's quite a bit farther away. So that was a major discovery. But within a very short period of time, Hubble made the discovery that overshadowed his first, I will say, in a propagandized form. What happened was, not only did Hubble compute the linear relationship, and there are famous graphs that you can find to, if you want to study that, it's well worth studying, but I'm going to summarize it now. Because what we're trying to explore and get to the bottom of is, where did this miserable theory come from? This ridiculous model which has become quite a problem for humans trying to understand science. If you try to find out what science knows about the universe from, for instance, Wikipedia, if that's where you like to start as I do, you'll immediately be overwhelmed, as if you were just hit with a tidal wave. And you just give up, unless you're absolutely determined, and then it's going to take you decades just to catch up with the mathematical interpretations. That's where Einstein comes in. Einstein's formulation, his theory, it's proper to call it a theory, his theory of general relativity, which has had such enormous success in space exploration, that was 1915, which is during World War I, actually. So it was only about 2 decades later that after Einstein discovered that space has a characteristic, which is curvature. And I know the meaning of that. That's one reason I give so many video presentations, is because the geometry that I discovered matches very accurately the discoveries made in quantum mechanics and cosmology. Because everything in the universe is spherical. Statistically, you can't say everything. There are linear aspects to the universe. For instance, well, we use distance, which is linear. But Einstein even blew a hole in that. And it's not difficult to intuit why there's a problem. It's because light takes time to travel. So by the time you've taken your measurement on a dead straight line to a star, the star is no longer there. Because it took time and for the light to reach you, 4 years for the nearest star, 4 years? Well, in that amount of time while the light is traveling, the object is still there. It's not just going to freeze in place, or nothing would move. Well, the light is moving and it takes time to move. It's called speed. And if it has a trajectory, which it does, we can compute the straight line in retrospect. That's velocity, because velocity is speed with a direction. That's what velocity is. They're not the same word. Speed has a more abstract. It's simply speed, which is distance over time. Well, you can see that's a 2-component number. We always have unitized time. Time is never figured into any equation until Einstein came along. You could say Einstein, Lorentz, Poincaré, there were a few other guys working on this, Minkowski, and they had figured out a 4-dimensional linear construction which has a pseudo-geometry. It's pseudo-hyperbolic. This does not actually exist in the universe, but it does exist in mathematical convolute space, which is very tricky, and it's bit us in the ass. Not me, because I actually got the right solution, but I don't expect you to credit that until you see the proof. The proofs are there in my videos but I should index them so they can be accessed so you can get this information. My paper is coming out shortly, and then you can consult the paper, which will have the proofs you need. For a spherical geometry, which is a two-component number system, matching speed is a two-component number, velocity is a two-component number, light speed is therefore a two-component number, it certainly is, and the distance traveled is in 1 second. Well, obviously that's unitizing time. But it is a valid relationship. It's a linear relationship between linearized space and linearized time. But neither space nor time are linear. Space definitely is not linear, and I don't believe anybody would argue with that. Distance is, though. Distance is how we penetrate space with our number system. To get a distance is quite simple, but it's quite artificial, and Einstein brought that out. You have to work in time if you want to, for instance, navigate, sometimes called astrogation. I've heard this word used. But to travel, even to Mars, you must use general relativity and special relativity conversions for the effect of time. But you see, time, what is time? Well, it's a derivative of energy. Because energy has motion, and time is related to motion. We have no perception of time without motion. Now, all of this is deep and actually quite profound, but I'm giving you some bracketing information to talk about redshift, which is an amazing phenomenon, but it requires interpretation, because the redshift itself is simply what can be observed in the light once you capture it. That there is this distance relationship that, for instance, the Coma cluster is about, I believe, about 100 megaparsecs away. Well, that's thousands of light years. How do we know it's that far away? Because of the redshift. And what is that? It's the shifting of the lines against the background. So what happened to the light is that the light has a frequency range, but it shifts toward the red. And what that means is it's losing energy, which is reasonable. But what it doesn't really lose is its coherent information, which stays intact. So something is keeping that light intact as it travels. Well, that's quite a long ways to remain intact. It's superlatively too far, because see, a spherical surface is constantly expanding, and the expansion is not merely toward something, it's expanding sideways. It's got to lose energy by definition, because light is always more intense near its source. But as it removes itself from its source at the speed of light, it's stretching. And that's the true interpretation of redshift. The light is stretching, not space. The light is stretching. So that's the rational, logical, straight. Now, is that true? Can that be proved? It's hard to... You could say it's obvious, but it's also obvious that the sun flies through the sky every day. Well, is that the right interpretation? No. It's due to the rotation of the Earth that makes it look like the sun is flying through the sky. Well, the same thing is true of redshift. You could say you have to proceed with the same caution. So what is said to explain redshift? if you read the Wikipedia article, you'll find out that there are at least 3 different kinds of redshift. I won't go into that now, although I will in the future. But it's worthwhile to know that there is more than one source of redshift, more than one explanation. Now, in the case of cosmic light, light that traverses huge distances of space, you would have to say no matter how many forms of redshift went into shifting to creating the redshift effect, the most prominent, the dominant, the statistically most important is the distance itself, which would have to affect the light. It's not a beam, it's not a laser. What you're getting is actually a fraction, or you could say infinitesimal. Well, it's not really infinitesimal, but a very small scope on that light, which is a spherical wavefront. It's not only hitting your telescope, it's hitting everywhere in the sphere that's centered on that object. The light went out, wouldn't be in all directions, but outward, you could say through half of space, a hemisphere of light. Well, it's actually more complicated than that. Although, I shouldn't say complicated, there's another aspect to that. The spherical propagation of light is one of the most baffling phenomena, and I believe it's the correct way to approach the quantum phenomenon, because if you can explain the transmission of light through space, you can solve the quantum paradox. No less than Paul-Édouard Maurice Dirac stated clearly, is on record as saying, the one problem that needs to be solved is the collapse of the wave function. The collapse of the wave function. Now, this does not seem to have a direct relationship with redshift, so I'm just going to leave that dangling for a moment. But you have to understand that in order to understand redshift, you have to understand the propagation of light. Now, what was quickly decided, based on Einstein's very recent discoveries in general relativity, that it can be proposed, hypothesized, that the cause of redshift is Doppler shift, one of the 3 types of redshift documented in Wikipedia. Is it Doppler? No, because it's not traveling through a medium. And that actually is not what the physicists, the astrophysicists, ended up saying. They ended up saying, basing their hypothesis on the recently discovered general relativity framework, that it's cosmological redshift. And that's brand new. That's not Doppler shift. And it's not gravitational redshift either, which is quite significant. We'll talk about that soon. But it's cosmological redshift, which is a brand new concept. The question then is that valid? What was put together as a theory to explain redshift is that the reason that there is a redshift is because space is expanding. And from that theory, you can extrapolate backwards in time. Because it takes time for light to travel, and it does exhibit this redshift, a linear relationship that goes all the way, but then that's to infinity, which is a very difficult concept to introduce into any theory. Is there's an infinity involved? That's a very, very difficult obstacle to the theory. So the way this was approached and formulated to explain redshift, cosmic redshift, is that it's due to the expansion of space for this reason: that if you extrapolate backwards in time, assuming that there is an expanding universe, this was the hypothesis, that the universe itself is expanding. Well, that means that space is expanding. So that's a characteristic of space. And since it's getting bigger, that's the theory, is that it's getting bigger. You could say that because of redshift. That's the reason for the redshift. They're inventing a new reason for redshift. Doppler shift does not quite do it. Gravitational redshift does not quite do it, because the speed of light is constant. In free space it is, we think. It's quite difficult to measure. There's a Veritasium video on what it takes to measure light speed, which is well worth watching, because he shows you can't measure it in one direction. You have to measure it in two directions, that is, back and forth, or you can't get the speed of light because of relativity. And even then it's hard to get. But it's now known so well that it was thought to just make it a constant, which is a kludge, but it's quite useful to have an absolute value for the speed of light, and that is official now, has been since the 1960s, that the speed of light is fixed for all time, because no one will ever improve on that speed. It is constant. But it's always in relation to the second, which is not defined. There's no way to define time. For the same reason, you can't define space without time. You can't define time without space. So they are related, but they're related linearly, and neither one is linear. So it is artificial. It is a derivative solution. What is a derivative solution? General relativity is. It's all based on a linear grid, which is a 4D grid, as an imaginary component, which is quite significant according to my geometry, which does have to take into account both infinity and imaginarity. I've done so. It's quite... That's why I'm producing the paper. But is it proper to say, is it proper even to theorize, that the reason for redshift is the expansion of space? What is being said is, when the spherical wavefront leaves the galaxy and heads out in all directions, it's going to hit everything in its path. It's trying to reach the edge of the universe. That photon is falling through space in all directions, constrained by its source. But it's still a spherical wavefront. It's not fully understood, you see. But that spherical wavefront goes out. That in itself explains redshift. There's no need for the expansion of space. Space, in fact, is not expanding. That's the alternate theory. Either space is expanding or it's not. Which do you think is true? Well, nobody asked you. Nobody asked me. These were physicists, astrophysicists, attempting to formulate, using mathematics, what is the reason for redshift. Well, in conjunction with the theory of general relativity, those two were put together in a way in which it was then thought it could be hypothetically stated, that is, theorized, that the reason for redshift is that as the light traverses space, space is expanding. So it is expanding with the expansion of space, and that is the source of the Big Bang model. That's true. The only reason that the whole universe is thought that it has a property such that it can be dialed back in time to see where it came from would be to contract everything in the universe back to a point. And it is a point, and nobody denies that. It's not an egg. It's a point out of which everything came. Well, that's a Euclidean point. It's null. It's the absence of any dimension. So that's the origin of the universe according to this model, is nothingness. It came out of nothingness. I leave it to you to decide if that's a scientific proposition or not. But it's already been decided in some way by the astrophysicists who all agree. They all agree. Now that's quite convincing to a layman. When all the PhDs agree, you are tempted to trust that. It's very similar to natural selection. By the 20th century, well after Charles Darwin's discovery, well, not discovery, his observation, that it looks like the genera speciate. That's all he said. It sure looks like those finches came from a superfinch, which means they must have diversified. They must have speciated. That's now known to be impossible, so that's not the answer. But that doesn't change a goddamn thing. It doesn't make any difference if it's impossible, if it's the only theory. Same thing happened with the Big Bang. Yes, it's impossible. No, space is not expanding. The universe could not have come from a null point. It's totally anti-scientific. If it were true, then science is ridiculous. But science is not ridiculous. We're able to deduce things about the universe using a logical process based on measurements. Well, in this case, the Big Bang is entirely based on one observation and not even on that, which has a legitimate explanation, which I suggest you accept instead if you want to understand the universe in any way. It cannot be expanding. That's actually psychotic. It's insane. But then you have to ask the question, then why do all of these goddamned PhDs all agree to the Big Bang model? And I'm going to leave it at that for you to figure out. I'll give you a clue. Who pays these motherfuckers? Okay, it's the government that wanted to get into outer space. Whatever the government is. That's why I've been covering religion lately. We don't know where we're from. We don't know where the universe is from. We don't know where the ecology is from. We don't know how galaxies form. We don't know anything about the fucking universe. Yes, we do. And we know enough now, according to my research, to decide all of these issues. From the Big Bang model all the way to the supermassive black hole geometry. And I myself have the correct answer that defeats natural selection. There is a scientific explanation for how the species got here and therefore how humans got here on Earth. That is actually the top question, but it's been forgotten, obviously, because your goddamn scientists have already told you what to think. Do they have to be right? Does it have to be natural selection? Is that law now and there's no other possible scientific explanation for the origin of man or the origin of the species? Is there no other explanation except the disproved theory of natural selection? There is no natural selection. That's now known. Well, there's no expansion of space either. That's now known. I proved it. So stay tuned. This is Anagalactic. I do get emotional because I'm getting ready to publish, and this month I'm going to live stream. Probably this week. So I'm very glad that you're tuned in. I'm sorry that I show some signs of emotion. It's very inappropriate for a scientist to do that. I have to, because I'm human. And I know what I know, and you need to know it too. You're quite blessed that you're tuned into my channel. I'll say that out loud against the atheists, and fuck you atheists, and fuck the natural selectionists, and fuck the Big Bang cosmological modelers. On all three of those points, I will not allow a scientist in my presence to just blithely state or assume that any one of those three goddamn theories is true. There is no natural selection. There is no cosmological principle. That is cosmological redshift. There's no such thing as cosmological redshift. There's no such thing as natural selection. And as for the black hole, we'll talk about that in the next video, which should be today. So again, thank you for tuning in. Keep looking up. I said in the last video that it was a waxing new moon. I am dyslexic. It's quite obvious I'm dyslexic. It's a waning. I think I did it again. I said waning. See, it's not a waxing full moon. I think that it's, God, I did it again. It's not a waning full moon, as I said. That would be getting close to the new moon. That is, in the future. But the new moon is past, and so it's a waxing crescent moon. I teach lunar geometry, and I'm willing to teach it to any age, because that's how every human being learns geometry. It's not from your fucking scientists who are lying pigs. They're paid to lie, and they can't get out. They would lose their jobs if they told the truth. So I do take compassion that way, just as heaven takes compassion on all of us. That's Islam. I'm of the Islam religion. I am actually a Christian. Well, a Christian is actually part of a religion that's older than Islam and Christianity. And as for the failed Israeli kingdom, at least we got the wisdom books out of it, and they did inherit the documents handed down, that is the documentation, all the way from before the Chicxulub impact, which is called the Flood. Stay tuned, we'll be right back.